This video presentation is a demonstration of the first beta release of SLIM from Intercax. SLIM, which stands for System Lifecycle Management, is a software framework for model-based systems engineering, connecting Sysml models with other engineering tools and repositories, including Plm systems and databases. In this video, I will demonstrate SLIM as a plugin for MagicDraw Sysml, with connections to PTC Windchill, Siemens Teamcenter, and MySQL. A second video is available showing the same capabilities for IBM Rational Rhapsody. We'll move quickly to the demonstration, but we have a few introductory slides. Since its beginning, Intercax has focused on model-based systems engineering and helping organizations adopt best practices. For us, the central concept of MBSE is that the system can be described as a single unified model rather than a series of independent and static documents. The nodes of this network represent system elements, requirements, behaviors, and the links between them represent composition, flow, dependency. The advantage of a single network is that it can be a single source of truth from which the systems engineering documents that we still need can be created. When one element of the system changes, we can use the links to trace and propagate the impact of those changes. And when the system model has been revised, we can generate a complete new set of documents with a few clicks of the mouse. Now, Sysml is a means for creating such a system model, but it is only part of the story, because each of the nodes of this network are linked to other tools, other models. For example, structural elements might be linked to CAD models, that behavior elements might be linked to simulation models, or spreadsheets, or documents, or graphics. In other words, the total system model is the Sysml model plus all of these other tools and models. So we think of the system model as being the Sysml model, which acts as a high-level roadmap of the system, as a clearinghouse for system-level data connected to all of the other tools and data models. Now, there are multiple challenges in achieving this type of confederation of models. The first are technical. How do we connect the different tools, particularly if they are distributed over a network, if there are access restrictions or firewalls? The second challenge is more conceptual. The concepts, not to mention the individual data models in the system domain or in the CAD domain or in the analysis domain, are such that we have to make certain decisions about how to map concepts from one area into another. And the third is that each of these models is constantly changing as the system develops, as are the connections between them. And so we have to be able to manage this change. We can look at the system model as being a series of snapshots over time. And of course, as different variants of the system are created and evaluated, we have different branches in this time. Now, SLIM is meant to address all of these challenges, but we are going to pay particular attention to the problem of configuration and version management, and the way in which Sysml can be combined with Plm Systems, product lifecycle management systems. Now, when we talk about connecting two different tools, we have to do that in the context of what we are trying to achieve by that connection. We've identified certain basic functionalities that SLIM must be able to perform. And the one is simply to create a persistent connection between elements in the Sysml model and in outside Plm systems or other repositories. Now, if the models already exist on both sides, we simply need to connect them. On the other hand, if we have a model in one tool, like a Plm system, and we want to create the same model in a different tool, such as the Sysml model, we need to be able to generate that second model, and then maintain a persistent connection between those elements. Once the connections are created, there are several things that we might want to do with it. One is to be able to check for differences that arise over time between the two models. And then secondly, we want to be able to update those models in either direction using those persistent connections. The fifth functionality identified here, the execute, it is to take an executable element in an external repository, a piece of code, a MATLAB function, for example, and be able to execute it as part of a larger system execution or analysis or simulation. But we will not be talking about that further. That's enough of the introductory slides. Let's move to the demonstration in MagicDraw of the SLIM technology. And we're going to do this in the context of a particular scenario or story. We're going to take the role of a system engineer who is required to integrate a system, in this case an unmanned aerial system, using information from multiple outside repositories. The first step is to create a very bare-bones Sysml structure in the MagicDraw tool, which we see here. In this case, it's simply a block-marked UAS, Unmanned Aerial System, which has a second block, payload. Now, our next task is to populate this using the external databases. So let's do this by launching the SLIM technology from the MagicDraw tool. We'll do this by right-clicking on the top-level package, UAV system, going down to the SLIM menu, choosing the dashboard, and this will launch the Sysml SLIM dashboard. Now, this SLIM dashboard has multiple tabs we can see at the top: Repository Manager, Connection Manager, Connection Browser, Connection Summary, Comparison Result, and Settings. We'll go through these in the course of the demonstration, but let's start with the Repository Manager. What we can see here is that we have already created links between this Sysml model and multiple outside repositories. If we click on the repository top-level item here, we can see that we have 6 connections already created. And of course, we could add additional links as well. The first of these connections is to my local disk repository. The second is to a MySQL database. The third and fourth are to Teamcenter repositories, and the last 2 are to Windchill repositories. Now you can see that we have more than one Teamcenter repository that we have connections. You can see that we need not only to be able to have access to these, but we have a user credential already. Now SLIM uses the protections, the security existing in the PLM repositories. In other words, in order to have access through SLIM to these repositories, I have to go to the repository administrator and say that I need a username and access privileges, which are assigned by the administrator. So SLIM does not allow you to get access to these repositories in any different fashion that you would have any other access to those repositories. But once that access has been granted, we can create links to those repositories that we can use in creating the total system model. So let's start to do the population of the model. We'll go to the second tab, the Connection Manager, and at this point we have the choice of the different repositories that we have existing links to, and I'm going to go to a Windchill repository, the vendor's Windchill repository, which contains their structure of the unmanned aerial vehicle aircraft platform. Choose that, and I will see immediately that within that Windchill repository there are many different products. I am going to use one from the UAV Sysml product, and as I expand that, you can see that I can see the contents of this PLM system, and that as I further drill down, I'm going to be interested in the aircraft platform. This is a top-level block. It contains the various characteristics of the UAV aircraft that I'm going to be integrating into my system. So as I drill down that further, you'll see that I have multiple different versions managed within this PLM system. And what I want to do is to take the latest version, Aircraft Platform A.8, and drag that into my Sysml model on the left side here. And since this is the platform, I'm going to drop it into a package that's existing in the Sysml model called platform. I'm going to confirm that I want to generate a Sysml block structure from the Windchill part structure within this item. So I see yes, we see multiple changes going through the bottom scrolling on the screen. And what we have created now is a complete structure of the aircraft platform taken from the Windchill Plm system at the vendor's site and recreated in the Sysml model. And if I go and expand aircraft platform, you'll see that it has a part structure itself, including body, electrical system, and so forth. If I go down to the electrical system block that's been created, it too has a part structure. In other words, we have got a multiple level part structure that has been brought over in one single task. So if I go back to the Sysml model and expand that, we go to the platform package, and we go to the aircraft platform. We take the block that is now created in the Sysml model, drag that into the block definition diagram. We can now create a part structure in which the aircraft platform is part of the UAS block. And we can further, if we, for example, want to be able to take out these individual parts and show how they are connected as well to the system. That's the aircraft platform. The other side is that we have certain elements that are going to go into this UAV payload that will be carrying out the mission. So as the system integrator, I need to go to a different repository to get information about those. So I'm going to go back to the connection manager. And at this point, I'm going to go to a different repository. I'm going to assume that the information I need about the possible components that could be used in the payload is maintained in a MySQL database within my own organization. So under here, under the test demo package, I have a table called components. And if I look at the contents of this MySQL table, you can see that it includes not only the name of the potential components, but information that has been collected about their cost and their mass. Now, in order to create the integrated system, I'm going to select a certain number of components from this database. I'll select a payload controller, a data bus, wide-angle IR detector, a radio modem, a communications controller. Let's stop with that. And I'm going to drag those 5 components into the payload package in my Sysml model. And I'm going to drag them in so that they are created as specialized blocks within the new system. And we can see that very quickly we have created 5 new blocks within the payload package that represent those 5 components. So again, if we go back to the Sysml model itself now, we can see that within the payload package we have those 5 new components, and we can drag those into the block definition diagram as well. And with a little quick rearrangement, we will add those to the structure of the model. And make those parts of our payload block. So you can see that in the space of a few moments, I have created a Sysml compositional model for the structure of our integrated system using existing information from a variety of different databases. Now, we have some additional housekeeping to do. For example, all of these new part properties that we've just created would probably need to have part property names. So we'll just give them some names as good practice. And of course, the aircraft platform itself is now a part of the UAS, so UAS has a new part property. We'll give it a name as well. But again, very quickly we have created a rather elaborate model for our UAS system in Sysml using information from these external repositories. This is the first part of the demonstration. The next part will focus on what happens when models change. When, for example, the contents of the repositories change or the contents of the Sysml model changes. Let's start off by thinking about the payload components that we just created. As you can see, for each of the payload components, the values from the MySQL database table have been carried over. For example, the payload controller has default values of cost and mass. It has a cost of 40, it has a mass of 2.5 kilograms. Let's go back and change the contents in the MySQL database and see how this Slim tool accommodates that. For this, we're going to go directly into the database itself. This is another engineer working somewhere else in my building. He is updating the contents of this. For example, he's decided that based on the latest information from the vendor, the communications controller is reduced in price. Instead of $50, it's now $25. However, the payload controller has gone up in mass. Instead of 2.5 kilograms, it's now 3.6 kilograms. So I am now making changes directly to the MySQL database. We'll apply those through the direct database MySQL workbench here. And now we have updated that information. However, the Sysml model has not been updated. It still has the original information. So if we go back to the Slim database now, we have to ask, how do we update the models? How do we see differences that have derived in the models? And for this, we're going to go to the connection browser. The connection browser keeps track of all of the connections that were created between the Sysml elements, the MySQL database rows, during the traditional creation of those Sysml elements. And we're going to use the filtering capability here to show just those particular connections that are not empty. And what we can see is that within that UAS system, there are a large number of different connections that have been created, up to 31 different component connections. And we can use those to look at differences that arise over time. So in this case, we're going to go to the payload package, and we're going to do a comparison between the Sysml model and the target, that is the MySQL database. And when we right-click and launch that, we create in the Comparison Result tab a difference table, where the red highlighting shows items that have changed across those connections since they were created. In this case, we can see that payload controller, the cost on the Sysml side, that is the source, is 50, but the latest cost in the database is 25. Similarly, the mass of the payload controller has increased from 2.5 to 3.6 in the latest. Having seen that there are now changes, we may choose to update the Sysml model so that it reflects the latest information from the MySQL database. And again, for this, we will go to the connection browser. We will go to the payload package, which will include all of the connections within the payload package. And we will sync target to Sysml. This will take the latest information in the target, that is the MySQL database, and update the Sysml model with that information. So if I choose that and confirm that, we can now make that change. We can see that those changes have been reflected. For example, the mass of the payload controller, the default value of the mass, has now gone up to 3.6 kilograms, in the same way that the communications controller cost has been reduced down to 25. So the latest information from the system has been transferred to the Sysml model. Now let's talk about the other side. What happens to the aircraft platform if we change it within the Sysml model? For example, because of this heavier payload controller, we may decide that it's necessary to have a second engine in our system. So I'm going to do that, in this case, simply by taking the existing engine block and adding a second part of the same kind. That here within the aircraft platform block, we've created a new part property. We'll give it a name. This will be engine 2. And now engine 2 will be changing the nature of the aircraft platform. So if we go back to our Slim dashboard and we look at the platform now and do a comparison, we should see that there's now a mismatch between the Sysml model of the aircraft platform and the original PLM vendor system. Now, since there are multiple components here, it takes a few moments to be able to make that comparison. But when we do that, we will see that a difference table has been generated. As we scroll down, we can see that there is a difference that has come up. Is that the source, that is the Sysml model, has a part called engine 2, and there is no equivalent part in the PLM system at the vendor. Now, we could update the PLM system from the Sysml model. If we wanted to do that, we could simply go to the aircraft platform, to the connection that's been created, and sync Sysml to the target. And this would actually go in and push this to the PLM system. In this particular case, let's do that. Note that the existing aircraft platform version is A8. And that if we now create a change in that PLM system, by syncing the Sysml model to that, we are going to make some differences. We are going to create a new version of the PLM system. So it's now A.9. And if we went and looked into the PLM repository directly, we'd see that a new version of the aircraft platform item had been created. Now, it may not be desirable to give the customer access to make changes in the PLM system, and this can be controlled by, for example, granting them read-only access privileges and requiring that, for example, an engineering change request would be generated rather than making the changes directly. But the capability for making these changes is part of the Slim technology. This has been the second part of the demonstration, showing that we can sync changes across the connections as the system model evolves. There are just a few other items that I want to be able to show. For example, one of the things that some organizations do is manage their requirements in a PLM system. So if we go, for example, to a third repository, in this case a Teamcenter repository, we can access the contents to that we are able to see. We expand the home here. We go down to a package marked requirements, and we expand that, and we go to fire UAV specification. I'm going to drill down through this and expose a specific requirement. For example, UAV endurance. I can drag requirements from the PLM database, from the Teamcenter database, into the UAV system model in the same way that I have before. I simply take a particular requirement and drag it over. Now, in this particular case, if we look, we can see that there are versions of the requirements that have been managed. In this case, this is A1, a version of this particular requirement, and that is the one that's been dragged over into the Sysml model. If I want to be able to go to my model, we can see that we have indeed created the requirement over here. We could drag that in. We can say even that we want to be able to create relationships between those requirements. For example, the engine will satisfy the endurance requirement, and we can create those relationships as well within our Sysml model, taking requirements from one repository, combining them with elements from a different repository within the Sysml model, our high-level roadmap of the system. The last capability that I want to show is that we may want to create a model, a PLM model, of the system that we've just created, the integrated system, in our own local PLM system. So we have the capability of that as well, taking the Sysml model and using it to seed a PLM system in a different repository. In this case, we'll go to a different Teamcenter repository, one that I have for example, write privileges to. And we'll go and we've created an empty folder here marked UAV demo. And what we're going to do is take the UAS system that we have created in Sysml, drag that over to the UAV demo package, and generate a Teamcenter part structure within our own local PLM system, which presumably we will populate with CAD files, documents, analyses, and so forth in the process. Again, we've taken a fairly complex system here that we've generated in our Sysml model and use it to seed our PLM part structure, which we can see in great detail here. So if we go down to the UAS system, we can see that its structure now is included. We have the platform and the payload. Again, if we go into the platform, we can see that it has its own contents, as does the payload, and we can drill down to as many levels of content as we desire within our system. This is the end of the demonstration portion of the presentation. To go back to a few final slides, for those who would like to try out SLIM, it is now available for short-term evaluation. To do that, go to the Intercax website, www.intercax.com/slim. Follow the instructions and contact us for an evaluation license. The SLIM product comes with installation instructions and a user guide. It also comes with a detailed set of hands-on tutorials to assist you in learning how to use the system capabilities. And please contact us at slim.intercax.com with any questions. The particular tools that are integrated in the first version of SLIM will be expanded rapidly. We hope to add additional Sysml tools, additional repositories, and other databases. We are also working actively on being able to connect CAD files to Sysml elements so that the design data created in a CAD file can be transferred into the Sysml model to evaluate its impact at the system level. If you have any questions, please contact either me, Dirk Swamer, or Dr. Manas Bajaj at Intercax. Thank you for your attention.